Hello dear students, let us see chemical kinetics lecture number 1.1. In this kinetics actually we discuss about speed of the reactions. In this chemical kinetics actually we discuss about speed of a chemical reaction, because in chemistry few reactions occur more slow and few reactions occur fastly also. So before going to discuss about chemical kinetics, let us see some definitions like rate of a chemical reaction. In a chemical reaction, usually a reactant will be converted into product. So with time, there will be change in concentration of reactant as well as the product. So we can define a rate of chemical reaction as the change in molar concentration of a reactant or a product with time. So we can give the formula as change in concentration of reactant or product by time taken for those conversion. So units of this rate can be mole, liter inverse, second inverse. Since concentration is measured in mole in liter as well as time will be in seconds. Later, let us see average rate. We have two different types of rate. One is average rate, second is instantaneous rate. Average rate is the total change in the concentration of reactant or product to the total time taken for a change. Whereas instantaneous rate can be, this is rate of reaction at any point or instant of time during the reaction. So with respect to reactant, we can take that as minus dr by dt, whereas with respect to product, we can take it as dp by dt. This R indicates the concentration of reactant. This negative term indicates there is decrease in concentration of reactant with time. Whereas this P indicates concentration of product, whereas this positive sign indicates there is increase in concentration of reactant with time. Let us see those definitions of average rate and instantaneous rates in terms of graphical representation. Let us see the graphical representation of average rate. Say R1 is the initial concentration and R2 is the final concentration of a F9 part. If R1 is the initial concentration of reactant as well as R2 is the final concentration of reactant during the time interval T1 to T2, then we can give the average rate as, so R2 minus R1 by T2 minus T1. Whereas instantaneous rate we can get for particular instant by the slope of this reaction we can get. So we can take this as minus d by dt of R at particular instant. We can express the rate of a chemical reaction when the coefficients of reactants and products are not same. For a general expression, A moles of capital A, B moles of capital B, C moles of capital C and D moles of capital D. Here the reactants are A and B and products are C and D. We can write the rate with respect to A as minus 1 by A dA by dt, whereas the rate with respect to B is minus 1 by B dB by dt. Here the negative terms indicates the decrease in concentration of reactant, whereas the rate with respect to product we can give plus 1 by C dC by dt, whereas the rate with respect to product D we can give 1 by D d by dt of D. These positive signs indicates the rate is increasing with time. If we see one example, ammonia formation from N2 and H2, here 1 mole of N2 and 3 moles of H2 are reacting to form 2 moles of ammonia. So the rate of this N2 and H2, if we compare, they should be in 1:3 ratio. And the same time the rate of N2 and NH3, if we compare, they should be in 1:2 ratio. So that with the consideration of those coefficients, we can write minus 1 by 3 d by dt of H2 in terms of hydrogen is equal to plus 1 by 2 d by dt of NH3, that is in terms of ammonia. But in this problem, they have given the formation of N2 and H2. The formation of ammonia they have given from N2 and H2, they are asking to calculate disappearance of H2. So the disappearance of this H2 minus d by dt of H2 will be 3 by 2 d by dt of NH3. Multiply the value of this ammonia formation with 3 by 2, you get the answer. And then let us see factors which affect the rate of a chemical reaction. So first I can take the nature of reactants. We have two types of reactants. One is ionic reactant, second is covalent reactant. So usually ionic reactions happens with the charge transfer. So they are very fast. But covalent reactions happens with the bond breaking as well as bond making. That's why covalent reactions are very slow. So we can say the rate of a chemical reaction will be high for ionic comparatively a covalent reaction. Then, if we see the presence of catalyst, we can define a catalyst as the substance which can increase the rate of a chemical reaction without itself being consumed in the reaction. So, this can increase the chemical reaction without itself change in any chemical change itself in a reaction. And it decreases the activation energy of a reaction so that rate of a chemical reaction will increase. Temperature. For every 10 degrees centigrade rise in temperature, there will be the double in the rate of reaction. We are going to discuss about this effect of temperature in collision theory of reaction rate separately. As intensity of radiation of light increases, so that chemical reaction rate of a photochemical reaction also will increase. Finally, let us see a rate equation or rate law. See, for a given chemical reaction A plus B plus C with the coefficient small a, small b and small c. Here, the equation which describes the dependence of this rate on the chemical reactants or active concentrations of reactants is known as rate equation. In this rate equation, this constant K is known as rate constant. We can define this rate constant as this is rate of chemical reaction per unit concentrations of all the reactants. And in this rate expression, if we take the sum of the powers of these concentration terms like P plus Q plus R, so we get order of a reaction. Thank you.